Hi guys, this is Miss Raina coming to you from C347 in MacArthur High School to talk to you about age structure. So remember, you can pause the video wherever you want to, stop, rewind, go back to anything you need to go back to. Use this to take notes and be ready for your quiz tomorrow in class. So an age structure is a histogram that tells how many people there are in each age bracket, and the age brackets are usually going by fives. They have a female side and they have a male side, and we can get a lot of information from an age structure from that histogram to tell us about things like birth rate, death rate, even things like infant mortality and life expectancy. So here are a couple of examples of different kinds of populations, and you can see by the shape whether they are developing because they're expanding rapidly. There are lots of pre-productive and reproductive age members of the community. If it looks kind of like a Christmas tree, then it's expanding slowly, and if you see some wobble around a pretty fixed value, you can say that it's stable. And if you see it actually looks like a decline, if you see this thing tapering towards the bottom, then you can tell the population itself is declining. So here are the examples again, if you want to pause the video and make a small sketch of each one. Okay, so here's how you tell the difference between a developing country and a developed country. You look at what we call pre-reproductive age, and that's your age, basically about 15 years old and younger. And so these first three brackets will tell you if a country's population is expanding rapidly or not. If we've got a big majority of the population here, you've got a pretty big expansion. If you've got a tapering population here, then you've got a population that is decreasing. So here they are, a little bit bigger. And I want to point out a couple of things about the scale. So each bar in these bar graphs here, in these histograms, is a bracket of 5 years in age. Those are going to be the same in almost every histogram. What's different is the x-axis. So on each side of the zero, one is for male and one side is for female. None of them are negative. They won't always be on the same scale. So in this case, it's in millions. In this case, it's in millions as well, but you'll see from your lab yesterday and from tomorrow, you're going to see sometimes hundreds of thousands or tens of millions here at the bottom. In some cases, like here in the United States, you'll be able to see a baby boom, and so you'll see a big, huge bar in the histogram that will go higher and higher as time progresses and as those members of the population get older. Just to review, each part of the histogram, each bar of the histogram is broken down by age. And so you can tell birth rates, death rates, you can even tell things about infant mortality. If the birth rate is higher than the death rate, that's the definition of population growth. And you can tell because you'll see that definite pyramid shape on either side that we looked at earlier. Okay, so here's an example of rapid expansion, and again you see this in millions, so instead of by hundreds it's going by twos. Stable growth is where birth rate almost equals death rate. It's not going to be perfect, it's going to look like a box toward the bottom, but if you have a look at it, this kind of oscillates around one value. And again, it's really important to look at the scale because now it says 0, 2, 4, 6, 8, 10, but these are not 8 million, 10 million. These are in thousands, so it's real important to look at the scale. Declining or negative growth is defined as birth rate smaller than the death rate. So here's an example. You see, at least for a portion of the pyramid, it's almost inverted looking. And so you can see it tapering off as it gets to the bottom in a very similar way to the way that it tapers off towards the top. Demography is defined as the study of human populations and their characteristics and their changes. And so we'll get to see a lot of really interesting information just by looking at the numbers of different groups of people. Population explosion is anything that causes the population to grow uncontrollably. Our example here in the United States is the baby boom when men came home from World War II and had a lot of fun, made a lot of babies. Exponential growth is when the population increases by the same percentage every year. So when we plot this, it looks like a rapid expansion. It just goes straight up like that, like the letter J. All right, thanks a lot for sticking with me through these notes. Make sure you bring them tomorrow. We're going to have a quiz over this, so ask any questions that you've got in class during the warm-up time. Thanks again. See you tomorrow.